Hey, what's up guys? Welcome back to the channel. On today's episode, we're going to be talking about this. The Synology DS1621 Plus. And we're going to be talking about maybe if you should be using it for 4K editing or video editing, or if you're a content creator and things like that. It's not going to be a full comprehensive review of this item exactly. It's going to be mainly focused around its performance and if you should be using it for video editing purposes. So stick with us. All right, you guys, so we picked this Synology DS1621 Plus up a couple months ago. It's been a while and we've been using it, so we can pretty much give you some ideas about it. We have been using Synology products for a while, ever since they first came out. I recently just upgraded to this one a couple months ago from a DS213J, I think, or something like that, and then also a Rackstation 2414 or something like that, somewhere around that. There was some rack station up there, but anyways, we still have those, but we picked this up mainly because it can do 10 gig purposes, so we're going to be talking about that. So this item, full disclosure, nobody sent this to us. We purchased this with our own monies. The reason it looks a little bit beat up is because it was actually shipped in this box, and we got a heavily discounted item from buying it from the Amazon warehouse. So it was, I can't remember how much ridiculous amount it was off, but most of you guys know on the channel, don't buy anything at retail price. So it was significantly discounted. I'll probably put it in the description below, but mainly because it was a used item, maybe returned use or whatever it is. But anyways, it's been working fine. So this is the box that it really comes in. We'll give you some stuff, basic stuff here. This is one of the newer models. So it's a 1621 Plus. So this one has the AMD Ryzen 4-core CPU. It has support for 2 NVMe slots. It has an optional 10 gig capable PCIe slot. It has expansion ports, and the RAM is upgradable. When you get it, or when it ships or whatnot, it comes with one 4 gig stick. It is upgradable, I think, to like 32 or 64 gigs if you're gonna be doing something like that. Although I would say the processor is probably gonna be limiting you. But I did upgrade my other models. You could probably check that in other videos with, I think it's called Arch Memory. It's a direct replacement for Synology RAM, and it works perfectly, significantly better cost and value oriented, but it still works perfectly fine. So, like I said, this is DS1621. If you don't know how to read that model number, how you basically read it is DS is a disk station lineup, so it's kind of like sits on your desktop type thing. RS like rack station and stuff like that. That's what the DS means. 16 is pretty much the maximum number of drives one system can be capable of. Okay, so in here this holds 6 drives right now. Okay, it has 2 expansion ports on the back, so if you add all the expansion ports and things like that, you can connect up to 16 drives to this unit. Okay, and you have a 21, so this model was actually released in 2021. Okay, so this is a 2021 model. That's where that comes from. Plus, so this is more of a value, more performance, a higher model tier than just the basic ones without the plus. A higher model one would, on top of this, would be XS Plus or something like that. So that's pretty much how you read that. Okay, so we're gonna get rid of this box. I did purchase this thing here separately. This right here is an Intel R Ethernet Converged Network Adapter X540-T2. If you don't know what that means, it pretty much means it is a dual port base T 10 gigabit Ethernet card based on the X540 chipset. All right, so we'll take you around to the back here real quick. So in order to install this card here, you do have to unbolt or unscrew 1, 2, 3, 4, 5, 6 screws. Take this thing off and you put the card in, and then you put it back in, and pretty straightforward PCIe card installation. There's really nothing to it. Okay, it does have vents. So the card sits right here, and most of you guys know PCIe cards get pretty hot, so it has vents right here to actually suck air through the vents, and then allows air to get to the heatsink, and then the system pulls it out on the back with the fans that are located here. Okay, so it does come with 1, 2, 3, 4 gigabit Ethernet ports, and here an optional 2 10 gig E ports, and it does work perfectly fine, no issues. On this model, this is a 6 hard drive model, okay? It does have a little key that comes with it. You can turn here so you don't accidentally unlock it. On my system right now, I did have it installed with this, I have to take them up, the Toshiba DT01ACA200. Okay, this is a pretty old hard drive, and we could probably go into the specs or whatnot and look at it. But this one apparently it says manufactured in May 2015. Obviously, since this is year 21, this is pretty old. Haven't been using it all the time. I do have another ZFS server with this with all these hard drives in it. It's been working out pretty well, and I had a bunch of spares laying around. And with the current COVID situation, with all the hard drives and IT and video cards and all that stuff on shortage, I didn't really think it was smart to pay a ridiculous surcharge on a hard drive. So I just pulled out some of the spare drives that I had and then stuck them in there. Okay, some of these drives I have been using in a previous disk station, so we'll go in there and figure out how long they've been on, but you could, all that smart data will tell you pretty much how much it's been used. So in this model, or I have my disk station set up with Toshiba, 6 of these drives and pretty much RAID 10, okay? And that's what we're going to be testing with today, because in reality, you really shouldn't be using RAID 0, I guess, if you're planning on actually making this like durable storage, obviously, because if you have one hard drive failure, you're pretty much screwed. If you're using this for a caching device, we're going to talk about why you probably shouldn't be doing that, because it's just not that smart. But in a real situation where you're actually going to be using it pretty heavily, you do not want to be using RAID 5. That should be deprecated. I think in most production environments it probably is. I mean, RAID 5 is great, but if you have one hard drive failure, your performance is severely impacted. A lot of people have issues and things like that. You can't even rebuild the array with the hard drives being at such big capacity without even having another hard drive fail during that time, or it just takes forever to rebuild it. Okay, so I would stay away personally from anything that's not RAID 10 or RAID 1. I would probably stay away from RAID 0 unless you have like multiple of these and you can afford the single one going down by putting it in HA. But I think if you're probably watching this video, you're probably not going to be doing that. So in a real situation, do not set it up with SHR. Do not set it up with SHR2. Avoid all that jibber jabber jumbo whatever. Use RAID 10. Okay, if you don't know what RAID 10 is, pretty much in this configuration with 6 hard drives, you have 3 mirrored sets. Okay, so you have these, like for instance, not this exact configuration, but you have 2 hard drives in mirror, 2 hard drives mirror, and another 2 hard drives mirror. And what that pretty much happens is you stripe all of those across the mirrors. That way in a way, you're kind of cutting your capacity a little bit in half or whatnot. Actually, probably more in half, but if I do the math, we can think about that. But you're losing a lot of capacity, that's for sure. But you are gaining a lot in performance. For instance, with RAID 0, you have obviously no write hit. With RAID 1, you have 1 write penalty hit, depending on how you want to read it. But with RAID 5, RAID 6, you get into all these nasty parity, read-write, penalty hits and things like that. And if you're trying to use it for video editing, you do not want any of that. You want to try to avoid that as much as possible, because video editing, scrubbing, high-speed scrubbing, and all that kind of fun stuff, you want to reduce the latency on that as much as possible, okay? So do not do anything that is not RAID 10, okay? That is going to, if you don't use RAID 10, okay, so be it. Just warning you, I would not do that, all right? So, interesting note here, I did run a few tests using an SFP card that has a Supermicro SFP card. Does work perfectly fine in here. I can probably throw a model number, a picture of it or something like that up here. I also did use, I think it was an Intel SFP Plus card. That works fine. I did connect it to the SFP switch and everything like that. But in the really short distances, if you're using it in like a business, in a household, and you're probably like less than, I want to say like 100 meters or whatnot, you're not going to see that much benefit from fiber over SFP Plus, or fiber versus copper, unless you're going long distances, or unless you're in an area that has a lot of RF type interference and stuff like that. But if you're using a good quality Cat 6A cable or better, you won't really have that issue, okay? If you are sitting in some kind of business environment and this is sitting probably, I don't know, 3 stories down or whatnot, or on the completely opposite side of the building, a couple hundred meters away, you should definitely be using SFP plus cards with fiber. Okay, that's definitely the way to go. But in a environment like this where I'm kind of using it at my house, and this is going to be sitting in like 2 doors down or whatnot, 3 doors down, different story if you guys know the band. Anyways, if you are using it in an environment like I'm using it in, you're not going to see that much benefit from fiber or copper. Okay, so let me go ahead and grab the computer. We're going to go ahead and connect to it. What I'm basically going to do is have this connected to the local network on a different, my basic local network, and then I'm going to connect directly to this thing using a MacBook Pro 16 with a probably like a CalDigit 10 gig Connect G type thing, and connect it directly here on a 172 or complete separate network. That way I can route to it directly without going through a switch, and we'll go through some of the benchmark tests that actually matter if you are doing video editing on an NAS. Okay? All right, you guys, and we're back here with the MacBook Pro Retina USB-C 16-inch, whatever you want to call it. This computer has, I think it's Thunderbolt 4 or something like that, but it doesn't really matter because this 10 gig CalDigit 10G Connect is only running at Thunderbolt 3. And it's fine because with Thunderbolt 3, you can still get 10 gig, all right? So let's give you a quick rundown of how it's set up. This MacBook Pro is connected to this CalDigit Connect 10G using Thunderbolt 3, using a Cat 6A cable that's roughly about, I want to say 15-20 feet to the rack station or disk station 1621 plus, which is right over there. Okay, it's literally, I could probably touch it if I had, I don't know, a little bit longer arms, but it is not within screen here, but it is sitting right next to us. Okay, so let's go into the computer. All right, so on here, we're connected directly. I'm just checking out some of the stuff here. Let's check out what we have going on here. On here, we have, see the drives here, like I said, they're not brand new, but it's been on for, I don't know, 4,613 hours. So it's not brand new, it has been used a little bit, but it's by no means old, okay? And just to tell you what we got going on here, let's go and check the network preferences. So if we go look at network preferences, we have this network. This computer is 162.2.14, and we are connected at manual 10 gig full duplex with jumbo frames enabled. Okay, so that's what's going on here. Let's go to network here, and showing the network, we are connected here at a whopping somewhere on here, I'll say 10 gig something. All right, here we go. Network status 10,000 megabits per second. That's 10 gig. Full duplex NTU 9000, which means jumbo frames are enabled. Okay, and what we also have going on up in here is we have created one shared folder, and then we have created another shared folder which is encrypted. Okay, so the main two differences here is it's the same thing. It's on the same volume, same stuff, running RAID 10, but one is encrypted, one is not. The main difference I want to show you here is that if you do use an encrypted folder, it does take CPU power to process or encrypt and decrypt the files that you're putting on there, okay? So it does have a performance hit. How much of a performance hit, we're about to go find out. But if the encryption thing, and if you're doing a lot of sensitive stuff and you're, I don't know, paranoid and you want to encrypt all that fun stuff, then you probably want to use encrypted, and then this may matter to you. But if you're really just uploading YouTube videos, no proprietary information, all that fun stuff, you may not care about encryption. Maybe you do, maybe you don't. I'm just saying. So we'll go and figure that out, okay? So the first thing I want to do is show you on here using 6 2 terabyte drives in RAID 10, the performance that you would get using disk speed test. So this is not So this obviously setup does not have the NVMe cards installed. The main reason we do not have it installed is mainly because when I'm mainly working in this configuration, the files and stuff I'm using on the NAS are not always going to be accessed because of where I have it in the workflow. I'll show you that in a little bit, but we'll go ahead and do that. Let's go here, let's select the target drive, and we'll go and select the target drive that is on this 1621P, all right, and we're going to select this shared folder, this unencrypted folder, okay? So we're going to be running this test, just let it go for a while and figure out what happens. So using RAID 10, we should be seeing some disk activity going up here, but it looks like we're getting mainly around maybe 400, close to 500 mega, it's capital MB, so megabytes per second, okay? Actually, what we should have done here was we should go enable resource monitor and try to figure out how that's going. All right, so we'll go to resource monitor. While this is going, we'll go to disks, and instead of utilization, we'll go look at transfer rate, okay? So transfer rate, this transfer rate is not exactly going to be scientific because it kind of takes an average over some certain time period and shows you what's going on, even if you don't have it on in real time. But see, so we're getting somewhere around 500 megabytes per second writes and 500 megabytes per second on reads, okay? If you have cache, the NVMe cache installed, it's going to look a lot faster, mainly because you're going to be reading and writing from the cache. If you have the read-write through cache enabled, that may not be true, but we'll talk more about that later. So what I just did here was I switched the file size to 5 gigabit file sizes or 5 gigabyte file sizes. See if it makes a difference. Sometimes it does, sometimes it doesn't. Depending on what you're doing, this is probably what you're going to be getting. So with the 5 gigabyte file sizes, we're getting roughly around 420 megabytes per second writes and 420 megabytes per second reads. I mean, that's pretty standard and you shouldn't expect too much more than that, but that's what you really get in this configuration, right? So this is the performance you would really see by connecting to a NAS using RAID 10. Okay, yes, there are faster drives out there. Yes, there are higher capacity drives out there. Unfortunately, I just don't have that with me. So what you can probably do if you did want to do this, you could probably fill the entire all 6 drives using like Samsung 850, 970 or whatever they make for the SSD portion. You can just slide them all in there and you could do that. That actually just gave me an idea. I may, after filming this video, I may go find some of those and then try to do that. But I don't have them right now, so we won't do that. But for this video right now, we're gonna focus on spinning Rust, okay? So this is the speed that you get using spinning Rust. So with that being said, you would think that this is a good thing to use for off storage, non-local storage on the NAS, but you would be wrong. Why? Mainly because the latency that you're going to be connecting through to the NAS is going to be big, all right? So how are we gonna measure the latency for each call and write? So there's actually a nice little tool called ioping. If you don't know ioping, it's literally just what it kind of does like a, if you know what ping is, it kind of does like a ping except to your drive. That way you can kind of see the latency that's going back and forth between your drive. So what we're going to do here is I'm gonna go to, we'll see what volumes are on here. And obviously if I do, let's do an ioping, right, to the local MacBook Pro hard drive. Okay, I'm gonna ping the local temp directory, which is obviously installed on this computer, directly attached, okay? So you gotta let it go for a little bit because sometimes it'll, depending on what the system's doing, it'll spike here and there, right? So look here, we have 14 microseconds. Is that nanoseconds? No, we're going microseconds. 14, 12, 17, 14, 16, 11, 79. So this is pretty much like the latency. Each request that you're going to be sending has roughly this much latency. So I don't know what the average really comes out to be just looking here. Let's just say it's somewhere in the teens, right? Let's say 15, 16 or something like that, okay? So every read or every write command that you're pulling in and out of the disk is going to be taking roughly 15, 20 microseconds, okay? So now let's take that same concept and try to ping the disk that's in the NAS, okay? So if I do an IO ping, actually I forgot what it was. So let's just do SF1. So in volume SF1, if we do IO ping, we'll do volume, we'll do SF1. So if I do a ping, it's going to be connecting from here through this cable, through this adapter, through this network cable, all the way into the system, and then eventually makes the commands and stuff throughout the disks. So now, if you look at it, each read and write request is going to be taking an additional, I don't know what the average is, let's just say like 800, okay? 800 microseconds. That's actually a lot. If you think about one one read or write request that was taking 10 microseconds, now one read and write request is taking around 500, 600, 800 microseconds. You've substantially increased the latency between the computer and the storage, okay? You might as well be using just spinning Rust directly connected to the computer. I mean, that's pretty much what you're doing now. So you're not really getting that benefit of having an SSD type system, because you're also you're pretty much having spinning Rust connected to the system, but also introduce more latency by going over the network, okay? So if in an enterprise world, things like fiber channel and things like that may have solved this problem, or not solved it, but reduced it or greatly mitigated it by certain means. But in a home type content creator type environment, you don't really have that I don't know, that benefit of being able to have all that kind of nice fun type stuff of equipment, okay? So therefore, I would not necessarily want to use directly editing on NAS, because you are introducing a lot of latency, and you will not get like good high-speed scrubbing, or if you do have to read constant cache and things reading back and forth, it's just not going to be good, okay? We're going to talk a little bit more about that later, so hold on to that thought. What we're also going to do now is we tested the unencrypted folder, and it got somewhere around, let's just say 470, 420, whatever, up to maybe 500 megabytes per second, all right? So now let's test the encrypted folder. So if I go back to the disk station here, go to encrypted, and then we'll test this encrypted folder with using 1 gigabyte files. So now using 1 gigabyte files on an encrypted folder, we have now decreased the performance to, let's just say, about half, at least in writes. That's usually what's going to happen, because as you're writing the file, the CPU and everything has to compress it, or has to encrypt it on the fly, okay? That's a lot of CPU power that you need to do, especially asking from this tiny little, I know it says it's a Ryzen, but it's not really an all that powerful CPU. It's not like the desktop Ryzen power, okay? So as you see, it's obviously going here, right? But you're not going to be getting that same performance you would be from an unencrypted folder, okay? Reads, you'll probably get roughly around the same. There's just not too much going on there, because it is already encrypted at that point. So let's just say 200 megabytes per second writes, 600 reads, okay? So now let's take, actually it's already still there. So let's go and select 5 gigabyte files, okay? 5 gigabyte files writes, roughly about the same. We're getting about 200 megabytes per second writes, right? And then now we're going to be getting, I don't know, let's just say somewhere on 400-ish, 350, 370 megabytes per second reads, okay? So by using an encrypted folder, we have now decreased performance even more. I know it kind of sounds like we're headed towards a lesser performance system, okay? But the main reason I'm stressing this is because this took me a while to figure out why the rack station, I think it was an RP2414, something like that, that I was using previously, was only getting like 15 megabytes per second writes and reads. And that was mainly because everything I was doing was encrypted. Just being a paranoid person that I am, and you just try to encrypt everything, okay? So in this case, I mean, this is just not really all that usable at this point. Think about it. We spent, I don't know how much this thing was. Let's just say it's like $400 or whatever on the system itself, and then a bunch of drives, and now we're connected to 10 gig. We got this interface card, and we have this adapter, and this, it's just not really worth it, okay? So to get the performance of video editing that you would want on over the network, this is not the type of setup that you would want. If you are okay with doing maybe unencrypted stuff, you could probably get away with it a little bit. I know probably most of the people watching this video are going to be doing their stuff all unencrypted anyways, but I mean, if that's your thing, then that's your thing. I don't do that stuff. So you get a lot of performance hit on that. So let's talk about where I do use this now. Okay, so if I do use this, I'm probably going to use this for probably just offloading footage that we record. Okay, so footage is going to be coming off the iPhone. We're going to be storing it pretty much all on here, like long-term storage. And then when we're editing, we're going to be pulling it directly into what we use, Final Cut, and then editing directly on the local disks that on the computer, or directly attached local disks through NVMe buses, okay? That way you don't have to have that additional, I'm just gonna round it off to like a millisecond latency trying to read and write and access the drive, okay? Doing that, because each read and write command to the drive is being delayed by an extra millisecond, that is astronomical if you count the number of reads and writes a computer has to make to disk every time, right? So that's just significant. It's just unbearable. It just seems like you spent like a lot of money trying to figure out how to get a performant video editing system, and that's just not really going to work. Okay, so for that reason, I don't directly edit on the NAS. If you don't care about high speed scrubbing or any of that stuff, and you don't need to work super fast or super fluently and all that kind of thing, then you probably don't care about that, okay? And you could probably make do with editing directly on there. But that kind of stuff really annoys me when you're trying to scrub and trying to find things and you're waiting for it to render and process and export. It just takes a long time, and I just can't deal with that. So I do not edit directly on here. I only use it to offload footage. For a while, I did used to edit directly on here, and we're going to talk about this in a second too. But this is also a bad idea, mainly because it will get super hot and then it will start thermal throttling. I will create another video in the future on what I did actually find out that works, which I would say is probably reasonable. And if you're a content creator, you could probably do that, okay? And I'll definitely recommend doing it that way, and I'll create a video for that in the future. But we're gonna talk about this. So this right here is a Sabrent or Sobrent or whatever you're from, depending on how you want to say it, Thunderbolt 3 enclosure that takes an NVMe 2 card. So in here I've put a Samsung 970 EVO, and we can run these exact same tests on here to try to figure out what's going on. And just for information's sake, I've only used this thing with encrypted. I don't do anything unencrypted around here. So this thing is going to be encrypted. So let's just see what it looks like when we plug it in, and then to get the numbers from there. So we plugged it in. It's going to pop up somewhere around here asking maybe to, there we go. So unlock this device. There we go. All right, so it is going to be there. Now what we're going to do is we're going to select the target drive in BlackMagic disk speed test. And it should be, is it this with the Final Cut library? Yep, this is the iMovie library. This is the drive I used to move my iMovie library to Final Cut. But anyways, we're gonna be using, directly testing the BlackMagic disk speed test on this device using 970 EVO, okay? Going to 1 GB files. So 1 GB file speed test using a disk speed test BlackMagic here, getting like 1100, 1200 writes, and 1300 reads, and this is using, I think it was Apple's formatted encrypted disk storage. All right, so this is what you would pretty much expect. So this is astronomically magnitudes faster than editing directly on the NAS. Okay, but what's downside? Downside, it's expensive, obviously, because you're using NVMe drives, and other thing is it's limited in capacity because you got one NVMe drive. Okay, there's a model they make too. I wouldn't really do with that, mainly because you have like thermal throttling issues, which this will have if you do edit directly on here. Okay, so this was a secondary solution that I've ended up with, and if you put a fan on there and cool it down, you could probably get a little bit longer, but you still run into thermal throttling issues if you are a heavy user and using it as caching device and backups and rendering. So to fully answer, go back to the other question of the latency that's going to be delivered on here. So if you look at the latency, let's go look at LS on volumes again, right? Look at LS on volumes, here we go, Samsung 970 EVO. So if I do an ioping, right, on Samsung, or actually what's going to be here is going to be /volumes on Samsung 970 EVO. Remember, going over the network was giving you roughly around 800, 900 microseconds, right? So if I do an ioping directly on this device, because it is using Thunderbolt 3, not necessarily USB, okay? Thunderbolt 3 has the direct availability to connect through the PCI bus on this NVMe drive. You're getting very close, if not the same numbers you would be getting by using your local disks on your Mac, okay? So therefore, using this external drive is significantly faster. Cannot even actually, you could quantify it if you want to do the math, but it's significantly faster, magnitudes better by editing directly on here. Okay, obviously NVMe drives wear out faster than spinning Rust. It's just not that doesn't make that much sense to do it on here. Actually, it really does. If I was a content creator, which I am, check out my other videos, my other channels, this would wear out very fast. And I think for a while, it works out fine. For a normal average content creator user, it's perfectly fine. It'll wear out, you just replace it. It's like a one-time buy that you have to buy maybe once every year or two. And to be able to improve your workflow, that would be the way to go. There is a better way to do this above this, and I'll talk about that, like I said, in another video. But because of the latency that's going to be introduced by editing directly on a NAS storage, not over fiber channel, like on your local network, I would not be editing videos on your NAS. And my recommendation is do not edit 4K or any video editing on the NAS. Only use it as a source of storage. Okay, if you're going to edit, I would edit on this NVMe drive. You can directly connect to the Mac. I'm not sure if there's any Windows computer and things that can do that. I'm sure there probably is, that can use Thunderbolt and do all that kind of fun stuff. But for a Mac user, I will do that. Obviously put a fan on there to cool it down so you can reduce thermal throttling, but that's where it really works out. So like I said, hope this video has helped you guys out. Stay tuned, because sometime in the future I will throw up a video on how to do the best way to do video editing for the average Joe or whatnot at home. So that's what I would do. With that being said, if you do have a NAS and if you're using Final Cut, I would probably use NAS to, like, if you go into your library settings, you can throw your backups and certain things like that in different places in your library. I would probably throw the backups to the NAS because it's going to be more reliable, consistent, always there kind of storage. I would probably throw things like cache or whatever, cache in your library either directly onto the drive or on your local computer, or you can actually just get 2 or 3 of these drives and just connect it and use one for cache, one for library, or one for direct editing, whatever you want to do. It all works out. I mean, if that's the way you want to do it, that is the way. It gets really expensive that way because you have to buy like 1 terabyte or 2 terabyte drives, and you got to buy these enclosures, which are like 60, 80 bucks or something like that. So that's what really works out. It's a good time saying no one sponsors this video. No one sent us all this stuff. This is all stuff that we bought and stuff that we learned through experience and, I don't know, general IT stuff. So like I said, hope this video helped you guys out. Stay tuned for a future video, and then we'll see you guys next time.